what about the problems? So the first customer that I mentioned, their kind of effective cluster size was 11,000, and they were scaling up to 15,000. They were starting to see Felix take a long time to converge after a restart. They were starting to see Typha struggle a little bit. So we designed Typha expecting that everything would restart in the cluster at the same time. And we tested that scenario. So you have hundreds of Felixes connected to your Typha, and you kill them all, and they all restart, and they all thundering herd attack Typha, try to take it down. We designed for that, but we didn't design for that and scaling up the cluster past 5,000, past 10,000, up into 15,000 nodes. So we're starting to hit timeouts, no like hard limit on the number of resources we could handle, but we had network timeouts and things that weren't getting honored. They were also seeing like restarting nodes that were heavily burdened, failing their health checks because we didn't have enough CPU to handle the big influx of updates at the start. I don't think that's boring enough. So we made a bunch of improvements, and these flowed back into open source. We tend to make improvements like this through open source and then flow them through into the enterprise product. It just makes sense for the core components. So these all dropped in Calico 3.25. Typha now shares the snapshot that it calculates when a new client connects between all the clients that connect at the same time. So that means if you have a thundering herd and 100 things all connect to Typha at exactly the same moment, we calculate one snapshot and send it all to all the clients in a binary format. We also compress the protocol. And when you put all that together, it means that instead of taking 3 seconds per client, which is kind of what we'd edged up to taking at these big scales, it's now taking 3 seconds to handle all of the clients that were connecting at the same time. So you have Felix connect, it waits 3 seconds to get all its data back that tells it everything it needs to know about the cluster, and all the clients that connect at the same time get exactly the same data at that same moment. So blasting some binary data out to a lot of clients all in parallel is very straightforward to do and very efficient. We also decided that even though thundering herd is going to happen, and that's what we designed for, we just decided it's going to happen, so we designed for that from the off. We also added graceful shutdown to Typha so that in a graceful upgrade scenario, you have more headroom and things shut down more gracefully, and the load moves from one Typha to another more gracefully. We also improved our metrics, so Prometheus metrics for Typha and Felix, so that we could understand what was going on at these higher scales and generally give a better picture of what's going on inside Typha if you ever need to debug that. Part of the problem that first customer was having was to do with kind of policy multiplied by pod scale, and that kind of comes on to the second problem as well. So I'm going to talk about that. So the second customer, they have a huge amount of policy applied to every single pod, and it's all the same policy that applies to every pod. So it's this kind of segmentation policy. But it was causing trouble both in the control plane and the data plane to kind of calculate that policy. And the way Calico works, when you have a lot of shared policy like that, we calculate it once for everything that uses it. But if you have 10,000 things attached to every pod, we'll calculate it once and it might take a few seconds, 10 seconds, 30 seconds or something, if it's really big. And then we'll use it for all the pods. But if you have a scenario where your first pod drops on a node and 30 seconds is too long and it dies because it didn't get network connectivity, and then it gets deleted, we then tear down that policy and then we recalculate it. So they got in this nasty spiral, and we had to do something about that.